على محمد وانزل مكة المكرمة in the time of Qiyamah. So today we are going to discuss banking of road, in which we are going to discuss what is the maximum velocity that a vehicle can have on a super elevated road, in which the friction between the road and the tires is mu s, the coefficient of static friction. Now I am drawing a vehicle in the form of a point so that the diagram will be easy to understand. So this is a body whose mass is m, so the force acting on it will be as follows. Mg will be vertically downwards, normal direction will be perpendicular to the surface, and the friction will be in this direction. Because when a body is moving on a curve, then it will be drifted away from the center. So the drift will be in this direction, and the friction will try to resist this drift. So the friction will be in this direction. So this is Fs. Now we will resolve these components, one towards the center, that is the centripetal force, and other perpendicular. Now see this Fs, if this angle is theta, this is 90 degree, this is 90 minus theta, this is theta. And this is the 90 minus theta, so this is theta. So this n can be resolved into two components, n cos theta and n sin theta. And this Fs can also be resolved into two components, Fs cos theta and Fs sin theta. And mg is vertically downwards. So this is the free body diagram of a vehicle on a super elevated road in which friction is also present. Now from the diagram we have n cos theta. Now see, since there is no motion in this direction, so some force along this direction will be 0. So n cos theta will be equal to Fs sin theta plus mg, because when the sum of forces along any direction is 0, there is no motion along that direction. We use the first law of motion over here. So then we have got n cos theta is equal to Fs sin theta plus mg. N cos theta is equal to mu s n sin theta. Why? Because Fs is equal to mu s n. I told you before that static friction or kinetic friction depends on the normal direction, and it may either depend on the coefficient of static friction if it's static friction, and coefficient of kinetic friction or dynamic friction if it is dynamic friction. So plus mg. So we have got n cos theta minus mu s n sin theta is equal to mg. Taking n constant, taking n common, cos theta minus mu s sin theta is equal to mg. Then n is equal to mg divided by cos theta minus mu s sin theta. Now the forces contributing to the centripetal force are those forces that are towards the center. What are the forces towards the center? N sin theta and Fs cos theta. And we know the expression for centripetal force is mv square by r. So mv square by r will be equal to n sin theta plus Fs cos theta. So we have mv square by r is equal to n sin theta plus mu s n cos theta. Because in place of Fs we will write mu s n. So mv square by r is equal to n bracket start sin theta plus mu s cos theta, because we have taken n common. So mv square by r is equal to mg. Why? Because the value of n is mg divided by cos theta minus mu s sin theta. So m and m will get cancelled. So v square by r is equal to g into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. That's what I have written here. Then r will go here. It will be v square is equal to r dividing numerator and denominator by cos theta. So we will have tan theta plus mu s cos theta by cos theta, that will be 1. Cos theta by cos theta will be 1. Sin theta by cos theta will be tan theta. So v is equal to rg tan theta plus mu s divided by 1 minus mu s tan theta whole raised to power 1 by 2, because when you are transferring the square on other side of the equation, then the square gets transferred in the form of root. So we will have root of rg tan theta plus mu s divided by 1 minus mu s tan theta. That is the expression for the maximum velocity that a body can have while being on a super elevated road at an angle theta with the friction and which the coefficient of static friction is mu s. That's all for today.